equals the momentum after. So another way we could say that, since mv before equals mv after. That's what we want to say in our problems that we're going to find. But I got to do some training for you. So, Brendan, this is a good time to start. We have to know when we can use that conservation law of momentum that we just shared from last class. And it's only when the forces, there are no outside forces acting on the system. So we have to discuss that. So I want you to take notes. I'm going to give you 6 scenarios, and you get to vote whether you think the law applies or not. But I'll be training you with each one, so you'll get better and better at it. So number 1 we started the other day was a tennis racket. So we had drawn a tennis racket and somebody's hand on it and a ball. So tennis racket hits the ball. So my question is, can we apply the law of conservation of momentum to this situation? And again, remember, the total momentum in the system will not change if the sum of the forces working on the system is 0. So we don't want any outside forces working on the system. So the question is, can we use that law in this situation? And the answer is no. So this is a no because, let me improvise. Do we have something I can use for a racket?
You can use a book.
No,
You could use a meter stick.
There's that box over there, looks good. Does that look like a racket?
Yeah.
Yeah, I think so. Alright, and here's my old string, so that's the ball. So if I hit the racket, I hit the ball with the racket, like that. The question is, is there any outside forces acting? Now, I'm not counting the forces in the system. Obviously, the racket is hitting the ball is having an effect on the racket, it's dimpling it, but I'm not counting those forces. Inside the system, all kinds of forces are acting on all kinds of each other. So don't look at the ball and the racket when you make this decision. But is there anything outside of that? And the question, and you probably see where it's coming from, is my arm. My arm is applying force and it is outside of the system. It's affecting this whole thing. So we cannot apply the law of conservation of momentum. So let me show you how we could. I don't know if I'll be able to do this, Brendan. I want you to very gently toss that into the air, and I'm going to hit it with the ball. Look out, Molly. Oops, I wasn't ready.
Okay. I'll say 1, 2, 3. You ready?
Yeah, thank you.
3, 2, 1.
Hey, all right. Did you see that? And now I've changed the whole scenario. If you got mad and threw your racket up and the ball hit it, then it would count. It would count because then there was no outside forces. My arm was not involved. I had tossed it in the air. So I could change this no to a yes, but it'd be an unusual way to play tennis. So, all right. So the next one, you got that one down? Tennis ball, racket with an arm is a no-go. All right, let's try scenario number 2. Let's do man on the skates. So here we have the man on the skates back in the Winter Olympics.
Is he a speed skater?
You know, he could be, but he's a figure skater. So the woman is going to skate toward him. All right, the woman's skating toward him, and she jumps into his arms. So, does the law of conservation of momentum apply in scenario number 2? The answer is yes. Now, obviously, there is some friction, but we discussed them the last time we had a lesson. It was Monday. We discussed that when it's reduced, we are going to pretend it's not there at all. So there's not much friction involved here. So we are going to fudge a little bit, and we're going to say yes. So you were saying, well, what about gravity? Well, gravity is pulling them down, but what's that wonderful force keeping them up? Force normal, so they balance each other. So there is no forces outside. Now I'm not talking about the man and the woman. She's going to jump into his arms. She's going to exert a force on him. She's going to use her muscles to jump. That'll have a force on her. So I'm not talking about what they're doing to themselves or each other. It's what is happening outside of this system, and we are saying there is nothing. We're ignoring air resistance and friction since they are both minimal. So this is a yes. All right, now you try this one from this great training. All right, you got that one? That was scenario number 2. Scenario number 3, rocket on a launch pad. And there's some kind of fuel on there that explodes and the rocket lifts off. So, I'll get you to vote yes or no on your paper there. Whether you think that there are, my question is basically, are there any outside unbalanced forces acting outside of this system on this scenario? Oops, my racket. Where's the ball? Oh. Yeah, that worked pretty good. All right, what was your vote? Point to your vote. Did you write it down?
I'm so scared now.
You're so scared.
I don't understand what that
We're asking ourselves, is there any outside forces on this? If there is, we say no.
I said no.
No.
All right, what do you got going on your
I'm
vote?
saying no.
I said yes, yes,
Yeah, I'm
Molly.
saying no. Oh, I said yes.
Molly, same.
So you're still
Probably wrong.
thinking?
I feel like
All right.
I'm saying no.
It's gonna be the M's.
The answer is yes. It is. The answer is yes. We can apply the law. So there are no outside unbalanced forces acting on this. Everything is internal. So we have the explosion. It's creating a force on the rocket, but it's contained in the system. What else is there? Gravity's down, but force normal is up. We have a little bit of air molecules preventing, causing some friction. We're ignoring those. So those who said no, what other forces did you see acting on here? Most of you said no. What were you thinking was outside? Yeah.
I was just saying like air resistance. I just didn't ignore it.
Okay. Okay. All right. We're going to get better at these, right? All right. Most of you said no on a yes. All right. How about this one? We have, draw this one. This is number 4. A car's going this way, and a car's going this way, and they hit each other and stick
The
together.
classic car.
Yep. So it's going to go from that to this.
Oh my gosh, the horror.
Alright. So I need a yes, no on this system. So you have one car rolling toward the other, and then they smash and hook together there. Is this a situation where we can apply the law of conservation of momentum?
Are there drivers in the car?
Yes. Okay. Only homework I'm going to add to this right here is to finish the pink, the front. Finish pink. What's that? What's on the front? 1 to what? 5? Number 1 through 5. All right. I'll get you in position to work on the back first thing tomorrow. Can you close
Do
that?
we know if the cars are yes or no?
The cars are yes.
Yes.